All right, so we are going to be applying ASA or angle side angle, right? Congruence. So determine if you can use angle side angle to prove the triangles are congruent. So don't read this. Let's just look here. We have these two triangles, right? What do we have? We have an angle. Those two are the same, right? We have this angle, which is the same. So we have an angle here, angle here, angle here, angle here. Do we have a side? Well, we do have this side, right? This side is congruent. But is this side an included side, right? So for it to be angle side angle, it would have to be this side right here. This is the included side. And over here, angles, it would have to be side angle. This would have to be the included side here. Do we have that that is congruent? We do not have that that is congruent. So we can't show that these two triangles are congruent because of angle side angle. We don't have angle side angle because we don't have any information about this side or that side. We do know that this side is congruent, but that is not the included side, so it would not be congruent because of angle side angle, which is what this is asking us to do. So it says two congruent angle pairs are given, but the included side are not given as congruent. Therefore, angle side angle cannot be used to prove the triangles are congruent. Okay, now you are also going to learn one that's angle angle side, and this would be angle angle side. So actually these angles are congruent, but they're not congruent because of angle side angle. They're congruent because of angle angle side, which you will learn in a little bit. So, okay, let's look at, check it out, example 2. It says determine if you can use angle side angle to prove that triangle NKL is congruent to triangle LMN. Okay, so here we have this lovely information here. Let's see if we can prove it. So the only thing I see, well, not the only thing, but I do see that these lines are parallel. With those lines being parallel, I think that we can, we have a parallel. This would be our transversal coming here. So if we kind of extend those lines here and here, we have a transversal. That would mean that this angle here would be congruent to that angle because of the alternate interior angles theorem. What else do we have? Well, we have a transversal here as well, but I don't think that helps us much. And we have a transversal here, but again, knowing this angle and that angle, those would be the alternate interiors, or this one and that whole one, which wouldn't help, which would be the same case over here with that being the transversal. So here what I see is that we have an angle and an angle, and then we have this reflexive property of congruence, right? So we know that this side is congruent to itself, but we would really need to show that this angle, because this is the included side, we'd have to have this angle and this angle being congruent. And right now we don't have that information. So we can say that KL, line segment KL, is parallel to line segment NM. Okay, that's given. Because of that, we know that these two angles are congruent. KLN, so angle KLN is congruent to angle LNM because of the alternate interior angles theorem. We also know that this side, NL, is congruent to itself by the reflexive property of congruence, right? But we need 3 pieces for angle side angle, right? 3 pieces. So we need an angle, we need a side, an included side, and we need another angle. So what we have is we have an angle here. We have a side here, which is that included side, right? But we don't have another angle. So because of that, we don't have all three pieces of information. No other congruence relationships can be determined. So angle side angle cannot be applied. All right, that is it for example 2. We'll see you back in a little bit for example 3.